Good afternoon, everyone, and welcome to today's webinar on bamboo, a promising construction material in earthquake-prone areas. First, I would like to introduce today's speaker, Dr. Jagdish Wangla, currently working as Head, EDC Innovation and Incubation Center, and Associate Professor, Department of Civil Engineering, PVP Siddharth Institute of Technology, Vijayawada, Andhra Pradesh. He completed his PhD from VTU Belgaum and Masters from BMS College of Engineering, Bangalore, and he has worked for 4 years in industry and 11 years as a scientist in research institution under MOEF, Government of India at Bangalore, and also he has worked as head of the department Civil Engineering in BMS IT, Bangalore for 2 years, and he also received several awards like INAE Best PhD Thesis Award, recipient of Boyce Cass Fellowship, Young Scientist Award by Indian Concrete Institution, Vishwakarma Award by CIDC, New Delhi. He has delivered around 150 invited and guest lectures at various national and international forums. Also, he has chaired and coached more than 25 sessions in international and national conference, and he has published more than 40 research papers in various international and national journals and conferences. With this introduction, now I would request Dr. Jagdish Wangla to deliver a talk on bamboo, a promising construction material in earthquake-prone area. Thank you, sir.
Thank you, one and all. Thank you for the introduction, Dr. Naveen. And it is the initiation of Dr. Naveen to bring me here to deliver this talk. Thanks to Amity University for inviting me to deliver this talk. So let me quickly go to my presentation. Let me share my screen. Yes, I hope you can see my screen now. Okay, thank you. So next 1.5 hours, I'm going to discuss about material which is most promising as a construction material, particularly in earthquake-prone areas. So outline of my presentation goes like this. I give a brief introduction about bamboo and bamboo-based construction, and then wherein I have worked in a Government of India organization, it is called IPIRTI. So during our time, they developed a bamboo housing system. And then briefly, I'll give you some of the engineering properties of the bamboo, wherein I have tested over a period of time as a part of my thesis and as a part of my work. And then having tested the properties of the bamboo, and then we have also tested various elements in the housing. And then I will also show you how a 2-story bamboo house looks like, and then some of the performance tests conducted. And at the end, as a earthquake resistant material, how it performed with the tests we carried out on shock table. And then finally, I end my presentation with the brief conclusions. After my presentation, I will answer some of the questions raised by the audience. And with a brief introduction about the bamboo, I'll start. In India, if you look, there are like 125 indigenous and 11 exotic species. And it belongs to different genres. Bamboo comes from a grass family. And then bamboo availability is about 14 million hectares in India. And then 2 million traditional artisans whose livelihoods are dependent on this particular material. You all know that northeastern states and West Bengal accounts for the most of the bamboo that is available in the country. So we harvest in the sense we cut and use it for different purposes, more than 13 million metric tons. This data is based on the India State Forest Report 2019 prepared by Forest Survey of India. And these are the top 10 states which are having the bamboo. And you can see here, Manipur having 6%, having the small area, and Madhya Pradesh is 13% with a huge area. Maharashtra, Arunachal, you can see the various states and its percentage of bamboo bearing area. And there are like main species like Dendrocalamus strictus and Bambusoides, Arundinaceae, Hamilton, which are in these percentages, what I've shown in 45, 28, 30. Out of the total bamboos, if you take, as I mentioned, most of the bamboo grows in northeastern part of India. You can see in the map also. And then Madhya Pradesh and then Maharashtra and other places. As I mentioned, there are two types of bamboos. One is clump forming and non-clump forming. You can see 67% is clump forming and 33% is non-clump forming. Quickly, let us know the difference between the clump and non-clump forming. Usually, they grow from the root of rhizome system. The bottom you can see here, there is a rhizome system. And there are two types. One is monopodial and then sympodial. That means for each rhizome, one single bamboo comes out in case of the monopodial, and then sympodial having the number of bamboos. Okay, so that is how it forms the clump and then non-clump. And very interesting thing one should know is in 2017, Indian Forest Act got amended, particularly for exempting the bamboo which is grown outside the forest areas, so that you can cut it and you can use it for different purposes. It is not like, suppose if you have to cut any tree in your campus, you have to take the permission from the forest officials. And by amending Indian Forest Act of 1927, so the felling transit permit for the transport and economic use has been improved. This is based on the Indian State Forest Report. Based on these, the calculations made by Jules Janssen, who is a very good researcher in this particular area, when you compare different materials in terms of energy production per kg of material, you can see here clearly bamboo is promising when compared with the other building materials. Even when you calculate the ratio between energy per unit stress, if you take, that is also bamboo gives a promising value when compared with the other building materials like concrete, steel, or wood. And as a civil engineers, we need to understand the orientation of fibers and how it acts and what are the properties. So to tell you, that the bamboo is a hollow inside in nature, and between two nodes, this hollow portion is there. If you can see here in the picture, if you split vertically, you can see both the halves of half split bamboo. If you can see both sides, so this is a solid disc portion. Whatever you're saying, this is called node. A node is a solid disc portion. Between two nodes is the hollow portion, and all the fibers run parallel to the axis of the color. And usually species to species, the variation is because one particular species having the more fibers within the system. If the more fibers are there, you need more energy to fracture the material. So that is the difference between different species. Typical specific gravity and average weight values are given. Per meter, it weighs around 625 grams or 0.6 kgs. And even though if it cracks, the individual fibers doesn't lead to spontaneous break, because the nodes will arrest the crack propagation. So you have to be very careful in working with the bamboo. When you try to nail the bamboo, what happens? These longitudinal fibers will give the weight to the nail. Unless like wood, what happens when you nail wood? What happens? Wood contains the radial fibers, so that it takes the nail into it. But in case of the bamboo, if it is a thin bamboo in the sense thin-walled bamboo. So this is called the wall portion of the bamboo. That is outside dia minus inside dia. So that is a wall. If it is a thin in nature, when you nail it, what happens? It gets split because the fibers will give a way to the nail. So you have to carefully work with the bamboo. And this is schematic representation. This is how the bamboo fibers are oriented within the cross section. So when it comes to the edge of the bamboo, that means the outer periphery of the bamboo, more fibers are located. When it comes to the inside the bamboo, inner portion of the bamboo, if you take the cross section, less fibers are oriented. And bamboo is used for various purposes. If it is less than 30 days, it is good for eating. A lot of people, they make pickle curries in Northeast. And 6 to 9 months bamboo is tender in nature. If you take out slivers out of the bamboo, you can make with that tendered bamboo slivers, you can actually weave the baskets and other materials, other furniture. And 2 to 3 years bamboo, usually they again make the slivers or strips, and it can be converted using the resin and make the composites, either bamboo matboard or corrugated sheet. A number of composites or laminates can be made out of the bamboo strip or bamboo sliver based composite. And 3 to 6 years bamboo is generally used for construction purpose. After 6 years, because it is outside and it is exposed to weather, it gradually loses its strength. Okay. So it is better to choose a bamboo of the age of 3 to 6 years. As you know, if you apply load, you might have seen outside the bamboo. When you apply load, it deforms. So bamboo can tolerate high deformations. It is obvious that when you make the house using the bamboo, those houses are ductile in nature. And these are the traditional bamboo houses you can see in the Northeast. Northeast is using the bamboo as a construction material from time immemorial. So wherein, this is the visit I made when I was working as a scientist to understand various houses that are there in the northeastern part. These are the various houses you can see, types of houses you can see. Bamboo is being used as one of the building materials. In the first house, they plastered with the mud the entire walls. Inside the walls, bamboo strips are there. Even in some of the houses, the walls are made with a lot of plaster. In the third picture, you can see it is a combination of plastered and unplastered, because whenever there are floods, this plastered wall will protect the house and not the water it will not get affected. The wall will not get affected. And then even they flatten the bamboo. They can split it into 2 halves, and then they flatten the bamboo. These flattened bamboos are weaved, and they can make the bamboo mat boards. And these mat boards are used as a walls. It's like fabricated walls. So they can make a framework using the wood or steel, and then they place these mat boards, and then they build the houses. These are the typical kinds of houses you can see when you go to the northeastern part of the India. There are like traditional bamboo houses that are there, practiced or there in the various parts of the world. These are the kind of houses that you can see in Colombian and South American country. There are like barrack system, wattle and dab system. You can see here within the frame, bamboo strips are placed and then weaved and then plastered and so on. Okay, these are the kinds of houses proven as an earthquake resistant. But in India, still, common people consider bamboo structures either temporary or unreliable. This is due to various reasons. I'll just list out 3-4 reasons, and I will tell what happened to address these issues over a period of time. Limited natural durability. Yes, in northeastern part of India, earlier they used to, place the bamboos once it deteriorated. They replace the bamboos every November. So because of the limited natural durability, people think that these structures are temporary and unreliable. And then there is a problem with the difficulty in joining various elements, and also lack of structural design data. Till recently, there was not much of data that is available with us. And then exclusion from building codes. For an interesting point to mention here, till 2005, National Building Code of India never mentioned bamboo as a building material. So first time in 2005, National Building Code of India, Part 6, Section 3, they were divided actually earlier they used to talk about only wood. And then they have divided Part 3 into Part 3A and Part 3B. 3A talks about timber, and then now 3B talks about bamboo. You can see National Building Code of India, and then you can go to Section 6, Part 3B. It talks about the bamboo and its various properties and so on. And then over a period of time, natural durability has been addressed by giving suitable treatments, and there are a lot of preservative methods and chemical treatment methods that are available, and a lot of joinery methods were developed over a period of time. Because of the various researchers and various scientists work, a lot of structural design data has been generated. People started using it. And this is what I'm talking about. First time National Building Code of India 2005, they've included bamboo as one of the building materials. So as I mentioned, bamboo can be converted into composites. So wherein bamboo, you can make bamboo mat boards, that is flat boards, and even the corrugated sheets or veneer composites. How do they do? Usually, as I told you, that the tender bamboo, they convert into slivers. These slivers weaved, and they make the mats out using the weaving patterns. There are two types of weaving patterns generally. You can see one is the rectangular pattern. The other one is the herringbone pattern, we call it. So when various studies conducted on these two types of patterns, they found that herringbone pattern gives more strength, particularly when you convert that into a composite material. So that is how you using these mats. These mats are dipped into resin, and then the dried mats again place it on a hot press. If it is a flat die, you get the flat board. If it is a corrugated die, you get the corrugated sheet. You can see both the components. Yeah, there is a case study. One Mr. Vipul Kumar Das, he constructed his house in 1973. So he weaved the arch roof kind of thing using the bamboo strips. So between the columns and beams are RCC frame structure. He wanted to go with the bamboo strip-based bamboo composite roofing. So what he did, he made the arch roof, and then he placed the mortar. After 25 years, he wanted to demolish the house. So before demolishing the house, he wanted to check what is the condition of the bamboo. So he stripped out the mortar, and then you can see after 25 years that 1.8 meter span arch, bamboo strip arch, still one person can able to stand on that that particular. What is it? From this case study, you can see if you utilize the bamboo properly, it can you can create a wonderful structures. That's what I meant by giving this particular case study. As I mentioned, I was working with the IPIRTI when we were with IPIRTI. When I was with the IPIRTI, IPIRTI developed in collaboration with the TRADA a kind of bamboo housing system. TRADA is a timber research and development organization in UK. So I will explain you what are the features of this kind of housing system. So this graph you can see in the National Building Code of India. This is the relation between moisture content to maximum crushing stress. So when you freshly cut the bamboo, that particular bamboo contains moisture. It is between 40 to 70% of the moisture. It varies. It depends on species to species and where you have cut. So once you cut the bamboo, you have to season the bamboo because you have to bring down the moisture content so that you can use that particular bamboo for regularly. What happens if you don't season it? What happens if you don't, bring down the moisture? You can see the moisture content versus crushing strength. If it contains moisture, the strength is like this. If it is the dried bamboo below 20%, you can see the strength. So strength increases once you bring down the moisture and season it to the required, the moisture content in that. And coming to the selection of bamboo for the construction purpose, you have to choose the bamboo of a diameter of 2 to 3 inches. 2 inches around 50 mm or 3 inches 75 mm. What I mean to say, the overall outside diameter, what you have to choose it, 2 to 3 inch for particularly purlins and beams. And for columns, you can choose the outside dia as a 75 to 100 mm. That means approximately 3 inch to 4 inch bamboos are preferred. And wall thickness is very important. you should choose a wall thickness having a wall thickness of 10 to 12 mm, so minimum. Again, when you cut the bamboo, what happens? It is a taper in nature. One side you have the one dimension, the other side you have the other dimension. So you have to see that least side, you should maintain a minimum wall thickness of 10 to 12 mm. And then internodal distance is preferable because based on the studies, the less the distance, more the strength. And you should not peel out the outer layer because outer layer contains the silica. Okay, that gives a lot of protection to the bamboo. And when you select the bamboo, it should free from any of the defects. This is the kind of grading you have to do it. It should not be more sweep in nature. And if you go through the National Building Code of India, they have given the grading rules like what kind of sweetness you should avoid. And definitely you should avoid the crookedness in the bamboo. So it should be as straight as possible, particularly if you are using it for columns, beams, or trusses. So the grading rules are given. So selection and grading is a very important parameter in the house construction. So coming to the treatment of the bamboo, treatment also plays major role because once you have the treated and graded bamboo, you can make any kind of structure based on your design or based on your interest. So treatment plays very important role. Usually, you go for 3 to 4 types of treatment. One is internodal injection, hot and cold, dip diffusion, and brochure process. In all these methods, you can use any kind of preservatives which are used for wood. But in this case, in internodal injection and hot and cold treatment, we use the oil called creosote oil. Creosote oil is a coal tar derivative, and heavy creosote oil, we use it for treating these bamboos. You might have seen the light creosote oil that is being used as a mosquito repellent in villages. That spray they do, right? That is like light creosote oil. So when you dilute the heavy creosote oil, you get the light creosote oil. Basically, the solid particle content in the creosote oil gives that heaviness in the creosote oil. So you have to use heavy creosote oil for this purpose. And internodal injection and hot and cold treatment, you carry out using the creosote oil. And then in dip diffusion method, we use boric peroxide solution. So you make you take water and make the solution using 1.5% of boric and anyway, I'll just quickly explain. This is the internodal injection method, the creosote oil. So between two nodes, you make a hole and then inject 25 to 30 ml of creosote oil, and then you close the hole with the wax plug, and then you rotate so that the oil gets uniformly spreaded inside. You have to roll it 3 times a day so that all the oil get absorbed. Why we are doing this? Because inside the bamboo you have the starch material. Starch is food for insects. That is why you are making the bamboo inside more insect resistant. In the hot and cold treatment, usually what we do, the column portion, basically bamboo use it as a column. So a portion of bamboo goes below the ground level. So what happens, this portion, you have to treat it using hot and cold treatment. You cannot go for the internodal injection. Why? Because you are going to bury the, the bamboo portion below the ground level. Similarly, like, when you go for the foundation buried under the soil, you go for the moderate, in case of the concrete, what we do, the concrete which you are placing below the ground level, you go for the moderate exposure. So exposure level is different, and then that's why you go for M25 grade of concrete. Similarly, because the kind of aggressiveness that is there in the below the ground level, so you have to treat using the hot and cold treatment. For this, you have to place it in the drum and then heat it for 1 hour, and then keep the bamboo as it is and cool it in the same oil for 24 hours so that the entire bamboo portion get treated. What happens if you don't treat it? You can see the treated bamboo, the portions. So there is a test called graveyard test. In graveyard test, you have the insect mound, you bury the sample of 6 feet length, sorry, not 6 feet length, 600 mm. approximately 600 mm. So 300 mm below the ground, and then 300 mm above the ground in the insect form. So over a period of time, you will observe what is the difference between treated and untreated bamboo, which one get affected. So this is the, after doing the graveyard test, you can see the untreated bamboo got deteriorated, and in case of the treated bamboo, it is fine. So that is the importance of treatment. The other method is a dip diffusion method. Here, if you take 100 liters of water, you have to add 1% of boric and 1.5% of borax. 1% is 100 liters, 1 kg, and 1.5% is 1.5 kg. So you have to mix it in the water and then make a solution. And then you dip all the bamboo or the all the whatever you wanted to treat, either truss, purlin, or split bamboo. You have to submerge in the water. You have to submerge for 2 days and then allow them to dry for a week. And then you can use it for the whatever purpose. Why there are two different methods, I will explain you in the coming slides. And like other constructions, because the load that is coming from the upper floors and the self-weight of the entire building, it get transferred to the foundation. But in a normal buildings, you have large and huge loads are coming. So, but in case of bamboo, it is very light in nature. So you need not go for the foundation more than 2 feet. Actually, one and a half feet, 2 feet foundation depth we go for. Anyway, in regular buildings, you have to give the anti-termite treatment. So after that, you have to place the columns. Wherever columns are coming, you're going for a concrete footing that is 1 foot by 1 foot. And then the rest of the places, you can raise the cement mortar or solid block masonry footing. And then these columns are spaced at a distance of 4 feet, and then one can go for even the 6 feet up to. I will explain you the span between the columns in the later slides, why you have to go, why not. So between the columns, these columns are connected using the top wooden plate, and between the columns, you place the strip grit. This is just like a balcony. You place the the fiber reinforced what is that ferro cement kind of concrete you go for. So here what you do, you place a bamboo strip grid of 6 inch by 6 inch between 2 columns, and then chicken mesh is tied to it, and then plastered 1 coat, and then wait for a day, and then it get harden, and then you can go for the final finish. So on top wooden plate, you can place the bamboo trusses, and over the bamboo trusses, you can place the purlins. Over the purlins, you can place the sheets, and these sheets are connected to the bamboo purlins. That's how you make the house. And there are traditional joinery methods that are available in northeastern part and also various parts of the world. The practice. These are, the basic joinery methods like full lap, butt joint, scarf joint, the bed joint. So using the natural jute fiber or bamboo, fiber, you can connect these, elements for making or converting into a proper truss element or any other beam element and so on. So usually natural material is used. This is a way of traditional joinery. But the problem is when you connect various elements like a beam or a column, using the natural or joinery methods using the bamboo or jute, due to the seasonal changes, due to the weather changes in winter and summer, due to the expansion and contraction, these joints get loosened. So what happens? The joint fails, and then the element fails, and then the house fails over a period. So that is why, in the sense when compared with the modern joining. There are modern joining practices by taking inspiration from the steel trusses or steel structures. You can see the gusset plate and nut and bolt concept. Same thing here, but here you need not use the steel plates as a gusset plate. You can use either the marine grade plywood or bamboo mat board or bamboo mat composite board as a gusset plate, and then you place the bamboos, and gusset plate is fixed on either side, and then using nut and bolt you can connect the bamboo elements. So just in a nutshell to explain you, this is the first stage wherein the bamboo is placed. This is a top wooden plate. In next stage, you have placed the small steel rods at every 6 inches, and the wooden plate, you have the nails. And then this is a 6 inch by 6 inch, that is the distance. And then stripped grid, bamboo stripped grid is placed, connected between these two columns. And then chicken mesh is tied. This is one coat of plastering. This is the final plastering finish. And then over that, you can place the bamboo trusses. You can see the gusset plate and then nut and bolt. And then above the trusses, you can see the purlins. It's a half split purlin. Over that, you can place the sheets. These sheets are connected. You know that regular, sheet connecting like J bolt and then J bolt and nuts and washers. Coming to the treatment, as I mentioned, already explained, let us see what kinds of treatments involve various portions. The columns, as I mentioned, brocherie process or the hot and cold or the internodal injection. In case of bamboo strip and other portions, you go for the dip diffusion. Why? Because these, the purlin trusses or strips are covered. Because the boric borax solution has a property of leaching out. I think you might have heard the boric powder, using it for our regular purpose. Whoever played the carom board knows, we place the boric powder. Whenever I ask, like, what is the boric powder is used, they say that, yeah, that is for smoothness. Not only for smoothness, the carom board is made up of wood veneer sheet. So to protect the wood veneer sheet for a longer time, not to get attacked, we keep on putting the boric powder and make it termite or insect resistant. Otherwise, what will happen if you keep it aside and if you don't play for 6 months or 1 year, you might have seen small powder that comes out of the, the carom board. So you can use even ponds or any other powder, but it won't be it won't serve the purpose. Smoothness, yes, it can serve, but if you need to protect the wood veneer sheet for a longer time, you use the boric. Similar kind of boric powder, we use it here. And borax is another form of combination, different chemical. Yeah, this is how the sheets are placed and connected to the trusses, and this is one of the inside view and then finished house. These are some of the houses in my old organization. And coming to that, as engineers, we need to understand what are the various strength and elastic properties of the bamboo. As a part of my thesis, I have carried out different studies on a particular species which is most commonly available in Karnataka, that is called Bambusa bambus. I have taken that particular species. I have carried out different tests starting from compression, flexure, shear, free vibration, and full scale tests. Let us see, if you look into the bamboo, as I mentioned, like, nodes are there. If you take a 6 feet bamboo, there are a number of nodes. Between nodes, you have a hollow portion. If you take the entire length of the bamboo, there are 3-4 combinations you can take out. So 3 combinations majorly I have taken out. One is completely hollow portion. One is if node is there at the middle of the bamboo. So I have taken 1 feet bamboo and then checked the what happens if it is a hollow, if it is in between, if node is on the either side. When we check the compressive strength, and we also have checked the stress versus strain, that is a modulus of elasticity value for this particular bamboo, you can see the values, MOA values and compressive strength values. So nodes will give you more strength to the bamboo. What does that mean? So you have a more contact area wherein it can able to transfer the loads effectively to the ground. So what does it indicate? Whenever you are placing the column in the ground, you have to make sure that the bottom portion and top portion is covered or filled so that it can effectively transfer the loads to the ground. And also, this is the kind of results we got. And even we have checked even the short specimens. What happens if the length change? So this is the 180 to 200 mm height, this is the strength. And even we have checked the shear test. Shear is very important parameter, particularly for bamboo housing. When you make the bamboo trusses, the number of joints you connect using the nut and bolt. What happens due to any of the forces? There is a movement of these trusses. When there is a movement, what happens? That transfers to the nut and bolt, the joinery portion. So there is a shearing effect that is there between the bamboo and the composite board. So it is very important to know what is the property of the shear. In case of the bamboo, we have designed a kind of method, and then we have checked the shear strength of the bamboo. This is the average shear strength. 7.78 we got for different specimens. You can see the range between 4 to 11 MPa shear strength for the particular species of the bamboo, what we have chosen for our studies. A very interesting study we have carried out by taking inspiration from some other material. So Arun Kumar and Saikya, this work has carried out at DMS College of Engineering, Bangalore, wherein they have conducted studies in making the columns and then taking and keeping one side fixity and then tapping the other side and recording the measurements, vibration measurements, and using the free vibration test, measuring the modulus elasticity of the bamboo. So we have done studies like we have actually casted bamboo is mounted inside the cube, and then fixity is created, and we have kept it, and then we just tapped it, and then we have measured the accelerations. So based on the data, what we got, you can convert that into compression modulus and tension modulus. Once you get the compression modulus in the previous experiment, so based on the combined modulus, you can even get tension modulus. That is how the experiment is being carried out. And even the flexural test we have done, and then we have carried out the studies for this particular species between curvature and moment. This is the stress versus strain, and this is the modulus of elasticity in flexure. And even full-scale tests we have carried out, particularly single and double bamboo columns. We have taken actual column length like 7 feet or 8 feet, and then we have carried out the test using the load test. Okay, and then we have carried out the the load test. You can see these are the values what we got, and the height is around 8 feet. So some of the observations for cracks observed, we could able to take a particular load, and a typical 7 feet bamboo of 4-inch dia of 12 mm thick can able to take half a ton of load without any deflection. That's what, based on the studies, we could be able to see. And then after conducting studies for 8 feet, we thought of also checking what happens in between 1.25 meter and 1.5 meters, and then we could you could see the values what we got for different values. As you know, when length increases, the value of the load because it buckles. So then we plotted all these results. Initially, we carried out studies for 1 foot bamboo and then the 8 feet bamboo. We would like to check then in between we have drawn the curve like stress versus slenderness ratio. You can see the values, and then the middle bamboo columns what we have tested fall within the range. We have also carried out the tensile test on bamboo strips, and many times people say bamboo is comparable with steel. Yes, it is comparable with steel on one particular property, that is the tensile property of the bamboo. If you can see the tensile property of the bamboo, tensile stress is around 75 MPa, and some of the bamboos are still higher, which is comparable with steel. Okay, that is what people mean. So having conducted the various properties on the bamboo of a particular species, we also use the same bamboo to make the different elements of the house and tested. You can see the wall elements, and then truss elements, and then roof elements. This is the IPIRTI-TRADA bamboo-based walling system. That's what I have explained in the earlier slide, wherein between 2 columns, bamboo is placed. This is of 6-inch by 6-inch, and then plastered. Mesh is tied to it, and then plastered on either side. This is the typical cross-section of the bamboo. These are the various tests we have conducted. You can see here. Shock resistance, impact test, racking resistance test, and a lot of joinery tests also conducted on these. This is a test conducted after I joined there, wherein I wanted to check. Many people are asking, sir, what is the the span between the 2 bamboo columns? Okay, the span between the 2 bamboo columns we used to go up to 4 feet. Then I have done a study. What happens if we go for 5 feet? What happens if we go for 6 feet? What happens if we go for 7 feet between 2 columns? Then after conducting tests, various tests, racking test, soft body test, light body impact test, soft body impact test, and various other tests. So we understood like up to 6 feet, there is no problem. Okay, and then even we have replaced 1/3 of the cement with the fly ash, and we understood like there is a finishability improved, and then the wall is good, and it is showing no damage with a minimal deflection, particularly for the arachnids. Yeah, many people ask what is the fire resistance of the bamboo. Here I would like to tell. If you take any of the bamboo, if it catches fire from the ends are like fiber openings, then it catches fire. Suppose if you keep the fire on the surface of the bamboo, so it blackens the surface, so it will not spread. To show you, once it converted into a composite, you can see here, fire is placed on a bamboo composite. It's a corrugated sheet. You can see, once you lit the fire. So they've checked it for almost till the fire ends. You can see it is blackening the surface. Okay, in the composite sheet, you can see the back side of the, this is the portion. Wherever occurs, it blackens the surface. That means it won't catch and it won't spread the fire. So just wanted to give you some kind of overview. I just showed this particular video. And then, having conducted number of studies, we also studied, testing different trusses. Starting with 3-meter truss, 10 feet truss, and then 4.27, 5.5 meter. And then we understood various types like king post, queen post, and different trusses we tested. You can see the results, and when we check the design load, so when we place the maximum load, so it is almost 2.5 times that design load it is taking with the minimum deflection or the maximum deflection, whatever the people say. So having tested number of trusses, we thought conducting studies only doesn't serve the purpose. We actually extended, or we have given this particular data and values and the truss details to for the extension part. Extension part is we actually, many people inspired, and some of the industrial shades, instead of going for steel trusses, they have gone with the bamboo trusses. You can see here in this picture. And then even the composite deck slabs also tested. You can see here, these same bamboo strip grid and then cement mortar is the similar kind of wall arrangement has been used for the slab also. And then we've also checked the composite deck slab, and it is taking the required load with a minimum deflection. So deflection is within the limits after checking the slab. So this is a 2-story house, and you can see the slab and the beams. What we have tested in the columns, we have actually by using the data, we actually built the house. This is a 2-story bamboo house. So the back side of the portion, we have raised it. The front portion is the same. So various foundation detailings. And you can see when we tested both single and double bamboo columns, and double bamboo columns were used in the backside portion of the house, wherein we would like to go for the second story. So wherever the load coming is high, in that places we have used double bamboo columns. And then you can see a little amount of steel is being used just to connect the various elements of the bamboo to the wall plate to the next column, which is coming on the upper floor. Nut and bolt is used. You can see this is a composite deck slab, and you can see the inside. Some of the construction aspects, as I mentioned, like if you have the more contact area of the bamboo, it is always take the more load. So to create the, because you don't know when you cut the bamboo and when you place it as a column inside the foundation, the bottom portion may be hollow. So what I mean to say is there may be a crushing that can happen. So what you have to do is you have to close that either with a wooden peg or filling it, so that you have enough contact area wherein the load that is coming from the top can effectively get transferred to the ground. Okay, so you have to basically improve the cross-sectional area of the bamboo. And these are some of the connection detailing in the bamboo house, wherein You can see the little amount of steel, different L angles, Z angles, in the beams, columns. You can see that this is a typical landing beam of the staircase, wherein you can see the column is coming from the ground floor, and then there is a beam, and then this column is going from the first floor column, and then this is the landing beam. How these connection detailing is very, very important in case of the bamboo house if it is a complex structure. Even the box windows also can be constructed. You can see here the bamboo using the same bamboo strip grid and chicken mesh and then plastered. You can make so you can use the L-shaped L angle steel rods. You can use it, and then it is connected to the main wall. You can see the box grid using the bamboo grid wall technology, box windows. This is the inside portion of the bamboo, and then that time it is like in 2007. Yeah, 2007. It costs around approximately 5.5 lakhs of 1,000 square feet. It is approximately 550 rupees per square feet. This is a better house which was done by our scientists who retired with the same kind of technology. You can see this is a 1:50 scale model. This is inside the finish of the ground floor of the house. And then you can see the kitchen and bathroom, nice colors you can give. And then these are the columns you can see and the trusses. This is the first floor portion. And then this is the balcony, nice balcony using the same bamboo elements, various trusses. This is a completed building. You can see the stairs, balcony, and then first floor. Coming to the performance studies on bamboo-based housing, particularly the seismic performance studies, having given the introduction about the bamboo, various species, treatment, and then various construction aspects and the IPIRTI-TRADA bamboo housing system, let us now understand how this bamboo house can be effective in giving the good seismic performance. So before that, I would like to give some kind of traditional concepts that are prevailing in northeastern part. There is this kind of IPIRTA type of housing system, where this is the kind of this is the house you can see. This house is made using the IPIRTA type. This is called IPIRTA type of housing system, wherein up to 1 meter above plinth level, they go ahead with the stone masonry walls. So above that, they make the wooden frames. You can see that green color or blue color wooden frames. Between wooden frames, woven bamboo mats are placed and plastered with cement or mud mortar. Even for the weed, what we call ikra, is used in both the walls and the roof portion. And these houses, particularly during the February 2006 and September 2011 Sikkim earthquakes, that wherein you can see the magnitude also. Due to these earthquakes, there was no injury was caused due to the falling. There are like falling of debris that happened, but there was no injury because lighting structures and there is no major injury that. But the only thing is, it may not be suitable for construction of storage because up to 1 meter height you go with the stone masonry. It is rigid in nature, and above that you have these kind of walling system. But this is also very interesting housing system wherein it is the earthquake resistant. When you look into the Colombian and other South American countries, these are the kind of barrack variants you can see. It may not be 6 inch by 6 inch grid. You can go ahead with any kind of barrack variant. Like, you can place the cross members and you can place any kind of design. Most of the designs are tested and then implemented at these places. And one more very interesting, housing system you can see in the Srinagar and other areas, that is called Daji Diwari construction. What Daji will do, Daji will take, pieces of cloth, he will stitch it into, the main element or the cloth, okay, or a shirt or whatever. So here also, you are having the wooden frames, between wooden frames, you are placing either burnt clay bricks or the stone you are going to place in this particular frames. So these timber frames, this Dajidiwari type of construction, because you are confining the the elements of masonry or bricks with the timber elements. so that the diagonal shear cracks will not propagate to one panel to another panel, and also out of plane collapse is reduced considerably because of this kind of this is the Dalji-Diwari construction you can see. There is one more type of construction, it is called tack construction, wherein large wood pieces are run horizontally. It is embedded. So above these horizontal runners of timber, they place wherever window is there, window frames, and other places they just place these stones or whatever elements. And this also improves the lateral load resistance historically based on various earthquakes. Reported by Roy and Murthy in 2006. So, as I mentioned, Dalji-Diwari construction, some of the students from Srinagar, they have carried out studies because timber is getting scarce. Why not you can use bamboo in place of timber? So they have carried out the studies using the similar kind of, the wall panel types. So they've done the bracings, different kinds of wall bracings, and they've tested it for lateral load carrying capacity. So when they observe, when they compare with the timber frames, this bamboo is taking almost 1.5 to 3 times better load carrying capacity, lateral load carrying capacity when compared with the timber frame. And these are the bamboo barrack buildings you can see in South America, Colombian countries, and other places where you get the sympodial bamboo. As I mentioned, these places like South American countries like San Salvador or El Salvador, they have these bamboo barrack houses. But 1986 San Salvador earthquake and El Salvador earthquakes, these houses also got affected, even though these are the bamboo houses. So when they found out what is the problem with it, and there are a lot of other issues, like, they used to go with the timber as a foundation. This timber used to get rotten inside, and there is not a proper connection between the different elements and so on. So these barrack houses also damaged. So what they have done, they actually made the structural barracks, and then they started conducting tests, monotonic loading tests on various these wall elements. And then based on the studies carried out at some of the universities, you can see in the cyclic loading test also of the structural barrack in Costa Rica, that based on this, they have built various colonies with the improved barrack system. And this is the undamaged barrack house after the 1991 Costa Rica earthquake. After the improved version is implemented and built the houses, these houses are undamaged after the earthquakes which occurred in those places. And I have also, as a part of my, the Government of India Fellowship, I have carried out some of the studies at Colorado State University, USA, wherein we have built, 2 different wall systems, and we carried out cyclic loading tests. That you have to make your own walls. Nobody helps there. When you go to the foreign university, you have to spend a lot of time making or building the elements. So these are the 2 walls I have made it with myself. You can see here the window, one with window and another one without window. So these are the finished walls you can see. So what we have carried out the cyclic loading test. And here, this is the protocol. 90 kilonewton actuator was used, and then the stroke capacity is 10 inch, the overall capacity, and 1 inch. We have given number of cycles, we have carried out the cycle. So after the test results, we observed that there is a crushing in the middle of the bamboo. Why, I will tell you. So the bamboo, as I mentioned, you have to use a minimum wall thickness. So here we get the minimum wall thickness, but there, luckily, this particular university, they have brought the bamboo for a different purpose. What is that purpose? Usually, the weekends, they go for the mountain biking. So when they go for mountain biking, if someone falls from the mountain, there should be some kind of barricades. So what type of barricades they wanted to do it? So they have brought the bamboo and they made the different barricades with the different configurations, and they've checked it how it can able to resist, because the bamboo can able to resist the impact loads very well. So they made the barricades. If someone comes and hits also, nothing happens, and then can able to search that rebound can happen, and those are said. Because of that purpose, they have brought this particular bamboo. These are thin in nature, but anyway, taking the worst bamboo and testing it is always gives you some kind of idea if someone can use the worst bamboo at the site, and so we have to go test it. Whenever you test it, you have to take all the conditions. So these are the in-plane cyclic loading experiments. Then numerically model the based on the data. So this is the cyclic loading and numerical data. That's what we call it as hysteric data. We got it for both wall with window and without window. So having known these values, we thought of numerically model the house itself. So already there is a house that is tested, that is a 8 feet by 8 feet house. These results we have given input in one of the incremental IDA analysis we have carried out using one software called SAPcode, wherein you can we can give the input of the earthquake and then give the house values, and then you can place the loads. So for different loading conditions, the drift and acceleration you can see. Suppose if you place 100 kg, 1000 kgs on roof, if you have 1000 kgs on the roof of a particular 8 feet by 8 feet house, this is what the percentage of drift to the particular spectral acceleration. But when we check both for 20 shallow US earthquakes and Bhuj earthquake, the responses were found to be very good and with low drift levels, even with the high seismic intensities, which are actually exceeding the design level. But the things are good. So these are the studies conducted at the University of Andes, Colombia for the shake table test and this two-story house. Just wanted to. Coming to the last part of seismic tests, I have conducted as a part of my thesis. You can see here seismic performance of a particular building can be assessed either using the shake table or shock table. So I will give you the basic difference between shock table and shake table. The first picture you can see is the shock table at Indian Institute of Sciences, Bangalore. And then I have taken a lot of help from them to build a own shock table at my institute during that time. And then the second picture depicts the shake table at this is the world's largest shake table that is there at the Hyogo Earthquake Engineering Research Center at Japan. You can see that. I happened to visit there along with my professor from USA. So we have like National Science Foundation projects. They have National Science Foundation project. As a part of National Science Foundation project USA, we have carried out world's largest shake table test on a 7-story 60 feet by 40 feet wood building. So I was the part of it. I was there in Japan for 2 months, and I have personally carried out a lot of damage inspection studies. Okay, let me give you some kind of difference between the shock table and shake table. You know that shake table can be simulated in 3 directions. This is only the one direction unidirectional moment, and the installation and operation cost is very less in case of shock table, very high installation and operational cost. Here you give the data in shake table, and then once you give the data, end of the test, you just have to check what kind of damage it happened. But here in the case of the shock table, 1 by 1 shock you give, and you can observe the shock pattern or crack progress in the building. And also, as I mentioned already, uniaxial and triaxial, and mainly used for simple building models, the shock table is used. And for any type of structures, shake table can be used. And in case of shock, as I mentioned, each shock we can study and we can check the response of the building. But here you have to check once after the complete input is taken, and then you can see after the test. So this is what I'm talking about. This is what I was involved in Japan in 2009. I was one of the damage inspection team member. You can just type it Nice Wood in Google, and then it is a National Science Foundation project. This is a 7-story wood building. You can see we were walking, there. Actually, we are actually doing some work. One is installation, and then after that test, it's a big test we carried out in July 2009. So I was actually inspecting during that time along with I have trained almost 30 Japanese students to inspect the damage inside. That was a very good experience, wherein each of the input given, we went there and then we were damaged. We were given with the bands. There is a systematic procedure to test any kind of a bigger buildings or a testing program. So you have to follow the proper guidelines. We trained actually, we get trained ourselves also what kind of procedures we have to follow after the test program, because safety is the major priority. So we did that, and then we have measured. So this is the shake table test I was involved personally. So coming back to our bamboo housing, wherein this bamboo house already tested at shake table, that is at CPRI Bangalore. CPRI having a nice shake table wherein they have like 4 meter by 4 meter. Yeah, I don't remember exactly. So on this table, this building of 8 feet by 8 feet building was tested. But what is the test? They have given input of zone 4 and zone 5 design input, and they did 30-second seismic simulation for each of the case. Even zone 5 was repeated 5 times. Why to repeat? To check the fatigue of the building. And then also Kobe earthquake data also given to test that particular building. After the entire test program, the structure did not exhibit any crack in any part of the building. So, to carry out the further studies, it is very important. Can you conduct the test? Who will fund? And even though if you test number of model, what is the output you have to test? So to test some more models, once I joined as a part of my thesis, I have taken, there is a cost constraint. And then you require a sophisticated facility. So each test they charge around not less than 5 lakhs. And then if you need to establish that facility, you need not less than 1 crore. And at the end of the program, vulnerability could not be assessed. So then I thought, having the previous record of, proven record of testing the building models on shock table by my guide, Dr. Raghunath, from the BMS College of Engineering, and his guide was K.S. Jagdish. And they've carried out a lot of studies at different places, like Nirma University campus, Ahmedabad, IT Roorkee, and this shock table is giving good results. Having the previous record, we thought of conducting studies on shock table. So I have fabricated the shock table. Shock table is mounted, and to design the shock table, it is very important. You have to know what is the building weight of the building. So typically, the bamboo building of 8 feet by 8 feet is approximately 2.7 tons, something like that. It comes less than 3 tons. Okay, so if it is a building weight is 3 tons, the 10% of weight your pendulum should be. This pendulum will hit the table. Over the table, you are going to mount the building, and then it vibrates. So you have to design the shock table. So there are, one is pendulum mass, 10% of the weight of the building, and the other one is you need to check the fundamental natural frequency of the table. What happens if when it vibrates, if the fundamental natural frequency of the building, matches with the fundamental natural frequency of the table, there may be a failure, or sometimes you don't get the correct values. So we have designed the shock table such that the fundamental natural frequency of the shock table comes to around 130 hertz or so. But when we tested the house, the bamboo house, the fundamental natural frequency of the building has come to 13 hertz. So it is almost 10 times more than compared with the fundamental natural frequency of the shock table. So this is the first model we have constructed, and then this is the model 1. This is 8 feet by 8 feet. You can see the column to column is 4 feet. You can see there are like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 columns. And then this is the test setup, and then we have mounted the accelerometers. Each shock. See, when you when you keep a particular angle of this pendulum, if you keep 10 degrees, it hits. So it generates a particular impact. When you're changing the angle, that means you are taking the pendulum to the top and leaving. So that the angle, when you change, the impact will be more. So you have to basically do the cumulative impact energy, and then you have to report, like for each of the impact, this is what we have observed something. So we got, for the model, 15 shocks we gave with the different pendulum angles, and this is relative energy. This is after the test program, we can observe the slight cracks. There is no major structural damage that was noticed. You can see the slight cracks we could observe. You can see. You can see the picture also. I just depicted. So having checked one model, we thought of checking the repeatability, and also we have not checked till the damage in both the cases. Shake table also they have not checked, and this particular first model also not checked. So we thought of going for 5 times, almost 5 times the more impact. So we have given 50 shocks, and would like to see what happens. And you can see the number of shocks, and then what are the angles, and what is the cumulative. What happened after giving 50 base shocks? To show you, this is a small video. This is at shock number 21 at 45 degrees. Pendulum will hit, and again we have kept a stopper so that it comes, hit, and then it gives a rebound, so that you get both the directions, the impact or the vibrations. Initially, we measured using the accelerations. Once we got after a certain point, we have removed the accelerometers and we only check the progress of the crack pattern. So this is the crack pattern that is observed after different shocks. You can see, just closely follow how the crack widens from 22 shock to 30th shock to 42 shock. This is at 22, then this is at 30th, this is 40. So the crack got widened at some places, the cement mortar got, and similarly this is the wall B you can see. Okay. And this is a wall C. You can see, closely observe, this is in the shock number 22. Light cracks are there here and there, small chipping. But here you can see, this is what it got widened. But there was no damage and there was no failure, major failure. This is up to 40. So after that, this is a shock number 50. You can observe the lines, whatever I showed is exactly it. So here, see here, there is a failure after the 50th shock, because we have connected the entire house with a U channel to the shock table using the nut and bolt and then welded, tack welding. So all the nut and bolts got sheared off because of the twisting. Okay, you can see this is the 50th shock we have given. So there is a twist that happened, and then so there is a failure that happened wherein we have stopped at this point of time. And this is the twisting of the house model. You can see the outside. Actually, if you see this, the bottom right corner of the picture, you can see here this actually channel should have been there in this corner. So this corner should match it. So this is the kind of the twisting that happened. That means all the bolts, nut and bolts got sheared off, and then it got twisted. But there is no failure to tell you. Actually, the base got failed. This is a closer look of the building. You can see here. Yes. So earlier slide, you can see this actually should be there in line with this particular eye section. But this has moved, almost come to the edge of the, this near to the edge of the shock. This is the crack pattern of the wall outside after final impact 50. You can see here. So I have embossed the cracks into this thing. You can see here. This is the crack pattern. So that is about the shock table studies. These are the embodied energy values. So we have calculated for different houses. We have like different houses. The regular house, IPIRTI-TRADA house, I told. One is timber frame, and then bamboo composite is placed. That is one house. And steel frame, and then bamboo composite is there. That is one house. Mud bamboo houses, RCC house. When you compare the embodied energy of different houses, you can see when compared with the RCC house, all the bamboo houses are less in terms of embodied energy values. And this is the cost, almost half the cost of the RCC house during that time. The cost may vary, depends on the number of internal walls and so on. And I've come to the conclusion of my presentation. Anyway, whatever you do, the development of bamboo structures depends on the availability of the graded material, and also you need to have the eco-friendly preservatives and preservative facilities. And you need to have access to design information like standards and codes, procedures to engineers and architects. And you need to train manpower in this area. That's why Building Material and Technology Promotion Council, Dr. Sailesh Kumar Agarwalji is a very good friend of mine. We used to have a lot of collaboration earlier. He's a very good friend of mine. I am still in contact with BMTPC director, and they promoted a lot of these technologies at various places. Particularly northeast part, they have built even the, some of the houses, and they keep training the manpower, and they associate with NGOs, and government is encouraging wider use of buildings. Some of the, as I mentioned, BMTPC, which is under Ministry of Urban Development and Poverty Alleviation. So in the end, based on shock table studies, it is evident that it can able to resist moderate to major levels of forces without minimum with a minimum damage, and compared with it, this is on contracts with masonry or concrete structures. So you can say the bamboo is a greenfield. These are some of the publications you can just go through. You can just Google it. These are the references. You can Google my name and space bamboo, and then you can contact me. This is my email ID and mobile number. Okay. Thank you, Amity University, for giving me this opportunity. Thank you, Naveen, Dr. Naveen, for providing this opportunity. So now they over to Naveen and participants. If there are questions, I will read out and I can answer. Otherwise, you can read, whichever is fine. I'll stop sharing.
Yeah. Thank you. Yeah, thank you, sir. Thanks for your wonderful presentation. You have covered all civil engineering applications for the bamboo. We have done wonderful research work, sir. I request participants, if you have any question, please post it in the chat box.
I'll just go through chat box. If there are questions, I'll just read out and answer it. Okay.
Yes. Before that, I have a few points I want to discuss with you, sir.
Sure, definitely.
Yeah. Sir, you have carried out that research work, that shock table, everything in IAC?
No. I have carried out at my old organization that is called, earlier organization that is called IPIRTI. So okay. I have actually.
And next to IAC, yes, sir.
Yeah, tell me.
Next to IAC, we have that Indian Institute of Bamboo Technology. One institute is there.
No, that is called IWST. That is called Institute. No. That is called Institute of Wood Science and Technology. They actually work with both bamboo and wood. But it is called Institute of Wood Science and Technology. That comes under ICF, for Indian Council of Forest Research and Education, which is under Ministry of Environment and Forest. So it's basically a sister concern of my old organization.
Yes, I remember one of my friend, he was working on bamboo for this shallow footing. He was doing in some, taking the isolated footing. He was checking that local shear failure or general concept he was doing. So he was frequently visiting that institution. Yeah, and now I've gone through your presentation. It was wonderful. I think my students will get some idea, and now they will get some inspiration to work on this thing. In today's class also, I requested my students to, who all are interested to work in this area, they can discuss with me. So this is the good area, so at least students will learn. In 2018 also, I think Dr. Ashish and one of his students, Sushant, has done MTech work on bamboo only for Dehradun, Uttarakhand. Yeah, that was very basic work, but that was good. In our department also we have started, but we have done very extensively. Yeah, that is good, sir. Suppose if my UG or PG students, if they are interested to work on this area, definitely I will contact you. It will be good. I need your support regarding this. This research.
Officially, I can even co-guide so that we can come out with a very interesting outcome.
This part we are discussing. Definitely, it's my pleasure. Now I request my participants, if you have any question, please post it. Otherwise, we will close the session by telling the vote of thanks. I think. Anyway, now it is now time for vote of thanks. I am thankful to all students, faculty, and staff for coming to attend this webinar. I am sure that the students, faculty, and the staff must be benefited by attending this webinar. And firstly, I used to thank our director, Professor N. Sridhara, for providing us with all logistic support to organize this event. And also, I sincerely thank Dr. Jagdish for accepting our invitation to be a guest of speaker for this webinar. And also, my special thanks to Mr. Ankit Batra and Ms. Sakshi Gupta for his support for organizing this seminar. At the end, I once again heartily thanks to all faculty, staff members, and students for their support. Thank you, one and all. Before closing, I request all participants to fill the feedback, so it will be helpful for us.
Yeah.
Anything you want to say, sir?
Thank you. Yeah. Once again, thank you, Dr. Naveen. And I have one more class because today I have 4 classes.
Okay.
Regular classes also I'm taking. Okay. Anyway, thank you. Thank you, Dr. Naveen, and thank you, Amity University, for giving me this opportunity to present my research work with you. Okay. I'm signing. Thank you.
Thank you, sir. Thanks a lot, sir. Thank you.